we're going to continue talking about inverse. Remember, inverse means opposite. His symbol is an exponent of -1, like this. Okay? And you want to think of it as the angle. To find angles, you use inverse. Inverse angles, inverse angles, inverse angles. So to find angles, you use the inverse. To find the sides, you use regular. Okay? If you think about it, remember I told you when I was in school we had to use the chart? Like we had to do sine, cosine, tangent, and then like you look it up, what was 1 degree, what was 2 degrees, what was 3 degrees. Well, up until now, what we did was we went down the side, found the degree we were looking for, and then went over and found what decimal we wanted. Okay, that's what your calculator was doing. Now we're going to go backwards. I'm going to know the decimal, so I'm going to know what that is, and then we're going to look up the angle measure. That's what inverse does. If you already know the decimal that's in this box, it goes over and looks and sees what angle that is. Okay? So without using triangles for a second, if I just want to find cosine, like the inverse cosine of 1/2, I do second function cosine, because you see right above the cosine is inverse cosine. So I do second function cosine, and then I type in 0.5. That's the decimal I'm looking for. Hit enter, and it's a 60-degree angle. Didn't we just do that on the homework? We said the cosine of a 60-degree angle was 1/2. So now we said 1/2. The inverse cosine of 1/2 is a 60-degree angle. All right? What is the angle that has a tangent of 3.2? What angle has a tangent of 3.2? Figure it out. What angle has a tangent of 3.2?
I know. 88. No.
I'm pretty sure it's 72.
Oh, 2.2. 1 second.
Okay.
72.
There you go. Okay? Everybody get 76 point? Okay, 72.65, 72.7? Okay. Right? Because you do second tangent, that gets me inverse, of 3.2. Now, if you get an error, there are like cosine and sine are not going to be more than 1. So chances are, if you typed in a cosine and got an error message, you accidentally hit tangent, or you accidentally put the decimal in the wrong place. So if you get an error message, don't panic. You probably just typed in, because there are values that cosine is not allowed to be. There's values that tangent's not allowed to be. So you just probably typed something in wrong. Okay? So just go back, type it in again, and you'll be fine. Okay? All right, so let's actually use it with triangles. Okay, here we have the sides of a triangle, but we have no angles. Okay, so that makes it impossible to do regular, right? There's no way you could type in tangent of an angle because you don't know any angles. So we're going to have to do inverse to find a missing angle. Okay, so let's say we're going to find angle C. Okay, the two sides we're given are what? Opposite and adjacent. Which trig function is opposite and adjacent? Tangent. So, and since I'm finding an angle, I'm going to use inverse. Inverse angle, inverse angle, inverse angle, inverse angle. All right, so you're going to do the inverse tan, which means what angle do I get from opposite over adjacent? Okay, so I go over here, I type inverse tangent of 7.5 divided by 5. Hit enter. 56.3. All right, now, questions so far? We good?
No.
Good. All right, two ways I can find A. What's the way we would have done it yesterday? Or the day before, or the day before?
Oh, 90 and 56.3 minus 180.
Yeah, don't, all the angles inside this triangle equal 180, right? So we'd subtract, so we'd say 90 minus 56.3 is 33.7, okay? Now, if I want to check my work, so we're saying we think this is 33.7. We're sure, because we know that works, but if I want to make sure that all of this is working, then I can find this angle by using the trig ratios, okay? So angle, am I going to use tan, sine, or cosine? Tangent again, right? Because I know opposite and adjacent. So I'm going to use the inverse tangent of opposite over adjacent. And it should, when I type that in, come out to be 33.7, right? Yeah, so rounded, because we rounded to tenths place on this one, so we need to round to tenths place on that one. So I do inverse tangent of 5 divided by 7.5, and I get 33.7, right? So it works. Okay? Just the same way, now that I know these angles, I could use trig to find this missing hypotenuse. What's the other way I have of finding the missing hypotenuse? Pythagorean theorem, right? See, right? Triangles are awesome. It just never ends in the amount of things you can find with them. All right. Take a second to find the missing angles, x and z. Okay, so for 32, since we're looking for sides, we use regular sine. We don't use inverse. So you can use sine of 32 is equal to x over 7.4. And this is a problem we just finished. It just occurred to me that we went ahead without recording. So these are the answers, 16.3 and 73.7. And then we went up to do this one. And the reason I wanted you to do this one is to see that you've got to remember when to use sine, when to use inverse sine. So in this case, we're looking for sides. I couldn't find angles because I only knew one side. So I couldn't use a trig function because I don't know two sides to divide. So instead, I'm going to find sides and use regular. So I used regular sine of 32 is equal to x over 74, and so I multiply both sides by 74, and that gives me 7.4 times sine of 32, and I get 3.92. So this side is 3.9. No, sorry. That's wrong. It's this side is 3.92 because we did sine. So opposite over hypotenuse. All right?